Hi guys, Mr. Johnny here. In this video I want to show you this. It's a dead LED projector that a friend of mine has given to me to take a look at. And yeah, it is dead. So the first thing I did is I took my watt meter, I plugged it in to see is there any consumption at all. And there was none. So I assumed that it is a power supply, the LED driver, which went dead in this, and not the LED itself. Two things that can fail here, the driver or the LED itself. This is a 10 watt version, very standard, very boring. There was a bit of mains flex, as somebody calls it, sticking off it. No, see, no earth wire, no nothing, just two. Live and neutral, if I got the color code right. It is pretty boring, pretty dusty, pretty crusty, but the fact that it's filthy is not the worst thing about it. So I took it apart, and even though Big Clive has warned me about little glass shards inside these things, I managed to poke myself to test it. And here, as you can see, this panel, this glass panel, which they just, I don't know how do they do it, they like score it and then snap it, and it produces a very jagged edge, and yeah, it's a mess. It also leaves a little glass shards inside, which can seriously hurt you sometimes. There is a seal, which is a nice silicone seal, so that works fine. Sometimes the real cheap ones have like hard rubber stuff which goes brittle over years. It's a total rubbish. Inside you can see the place where a driver used to be and the LED itself. Somebody already took it apart and yeah, meshed this screw, so I can't really undo it, but fortunately I can spin this reflector around, which is very thin foil. Here you can see a LED, 10 watt LED, which is in this case the 30 volt version 1, where all chips, all 9 chips inside are hooked in series. Alright, so now the driver. The driver was this little box, which I just looked at it and like, oh, there's no way it's gonna be 10 watts. And what do you guess? It is 4 watts. Now this driver was potted, but you can see there is nothing inside anymore. Well, that's because I took it out. The potting, the compound that it was potted with, is surprisingly easy to take out. Here is some of that compound. It's this thing which tears quite easily, as you can see. Very easy, quite easy to take out with a little flathead screwdriver. No wires there. So let me show you the driver itself and not this little box which has no use for now. Well, the driver looks like this. It is minuscule little thing. It is the size of a thumb, see? Very, very small. This is 22 millimeters or 3/4 of an inch by 15 millimeters, which is just a little over half an inch. Okay, this thing is very, very small, and you can see a light bulb hooked to it. Well, that's a ballast to prevent this exploding in case I did something wrong. There's not much parts on it at all. Minuscule little device. Let me try to show you. There is your bridge rectifier phone has a hard time focusing on this little beast. There's a bridge rectifier, bulk capacitor, a little 3-pin chip there in SOT23-3 package, a little 8-watt resistor, a little 0603 by the looks of it, ceramic multi-layer capacitor, a diode, a resistor, another ceramic cap, and a choke, and that's it. 9 components, if not including the LED itself, which is separate to the driver. So 9 components. There is no fuse, but there is fusible track, which you might be able to see. That's where this pad connects. There's little fine tracks swerving around. Not sure if you can see that. It's very tiny. You might be just able to see a track right there snaking around. Let me boost the light a little bit. So I even, since the scene is so simple, I also reverse engineered it. But first let me hook it up to this LED, which is 10-watt LED, but this one is a 12-volt LED. But it doesn't matter. This thing is a current source, so it's gonna be the same, or almost the same. I'm gonna point it away so I'm gonna get blinded. And yeah, don't do this experiment yourself. You can see live components all over the place, but you can see LED glowing, alright, and you can see that the current is about like 150, I'm gonna say, milliamps, which is not much. And this LED is a 12-volt LED, so right now the circuit is roughly 2 watts. I'm gonna round it to that. And if it is a 30-volt LED, it's more like 27 times that, so like 4 watts. Far cry from 10 watts it advertises. And the schematic. Schematic is this little bodginess, where you can see, you already will understand why I try to parody here. Mains come in, but anyway, mains comes into the bridge rectifier, goes to the smoothing bulk capacitor. Positive from a bulk capacitor goes directly to the LED. And the LED also has this 470K resistor and that ceramic cap across it. Then there is a diode, cathode of which is connected to the positive supply here. And there is a choke between cathode and the anode of this diode. And this arrangement is your typical buck converter. This chip switches the inductor, and if this chip switches on, it effectively shorts this and this lead together with its internal switch, so the current flows from the capacitor, which gets charged up from the mains, like that, through this current sense resistor, and back into the cap. Now when the switch turns off, it opens, inductor still wants to keep current flowing through it, and as previously, the voltage across it was like that. This end was positive, this end was negative, and it's flowing just fine. But inductor still wants to keep the current flowing, and to do that, it will change the polarity across it. So now this end is positive and this end is negative. So the current now flows through this diode and back through the LED again. This resistor is a 2 ohm resistor, which is that little 8-watt beast on the board, which is absolutely tiny. It may get warm under load, I don't know. The capacitor is 4.7 microfarads, which is not much, but then again, for a 10-watt driver, this is too small, I would say. But for a 4-watt driver, perfectly fine. The most crikey part about it is the fact that it's a buck converter, it's not a flyback, it's not an isolated supply, as you can see from schematic. It's not isolated at all. And this LED is fixed like that, and there is absolutely no tape, no nothing under these lugs where you will solder the wire onto, and if you happen to do like that, it might be touching, and yeah, it's crikey if you ask me. I'm gonna put some tape on it and hope that LED is well insulated from its base, because if not, bad stuff will happen. And as I mentioned already, this came with a 2-wire cable, only live and neutral, no earthing, no earth conductor, protective conductor, so yeah, very crikey. So that's it, guys. A minuscule little, and I completely forgot to tell you what the problem was. The problem was that when I took it apart, this was connected to the module, and it was going through these holes like that, and into the porting. Now, this brown wire was soldered to the board, but this one wasn't. This end is properly, more or less properly tinned, this little wire, but the thing is that it had a dry joint. This wire was soldered to the board right here, and it was a dry joint, so it just, with a little tangle or vibration, it just worked loose and the thing stopped working. Oh, I am a moron apparently. That's the main side. It was here. Yeah. So that's it. I'm gonna now reinstall it. I'm gonna wrap it around with some Kapton tape, then pot it with hot glue. Not completely, but so it will, just enough so it won't wobble around. Okay, a little add-on to that video. Right now I omitted the ballast from the circuit. As you can see, LED is still glowing, alright? You can see the same current, just like as it was, and this is, my LED is a warm white LED, which you can see from the light apparently. And let's measure voltage across it. And you can see it's about 9 volts, so it's less than 2 watts even. A very small power. Now let me connect to the original LED and show you that it doesn't make a difference for this current source. The current will be the same anyway. No, I'm trying not to shock myself. Okay, now it's not ideal current source, so the current may be a little bit different, but the overall concept is the same. Oh, 152 instead of 155. Ah, crap, it is bright. So let me put the leads where they should be before I turn it on. And you don't see what I'm doing. Well, oh, of course, 20 volt range. 29.7 at 152, so precisely 29.7 at 152 is 4.5 watts. Not much. A far cry with a WAS Montenegro from 10 watts, it says. Anyway, so that's it. I'm gonna cobble it in, and yeah, and it will be working again. There is a saying in that electronics has only 2 kinds of problems. There is contact where it shouldn't be, and there is no contact where it should be. Well, it was the second case in this situation. Okay guys, so the thing assembled. Let's stick it into the wattmeter and see how much power it consumes. and we know how much power the LED gets, we can calculate efficiency actually. And yeah, this, no plug, so yeah, definitely, if you're not familiar with this kind of deal, don't try this. And again, it's not isolated, but I took some precautions, so hopefully I won't die during this video. I did a modification to my watt meter, so this is now 10 millivolts per watt. So to get watts, you need to shift the decimal point one place to the left. We get 5.3 watts, good enough. Accuracy, which is on the output we got 4.5 watts, on the input we got 5.3, was it? I'm getting old already. Yeah, 5.3. So that means 85%. Good. That's just fine. 85% is good enough for me, if you ask me. That's it, guys. Thanks for watching. See ya.